In this presentation, I will be explaining Pythagorean theorem as a sample lesson for students in a high school setting. The three major learning objectives are that students will be able to identify and recognize the hypotenuse as the longest side and is opposite to the 90-degree angle in a right triangle. Secondly, students will be able to identify and recognize patterns in relationships between the hypotenuse and the legs of right triangles. And third, students will be able to apply their knowledge of Pythagorean theorem to find the missing side in a right triangle given real-world context. To start the lesson, I will begin by activating prior knowledge from the previous lesson students learned that in a triangle, the longest side is the side opposite to the largest angle, and the smallest side is the side opposite to the smallest angle. As you can see in this interactive tool, the longest side is always opposite to the largest angle, regardless of the type of the triangle. So in this case, for example, the largest angle is C. So the longest side opposite from C is side AB, and that's the longest length. If we modify the triangle, with now the largest angle being angle A, we can see that the longest side is BC with 25.3 units. If we modify it again, with now angle B being the largest angle, 96 degrees, we can see that the longest side, AC, is now 31.7 units, and it is the longest side out of the three sides. So side AC is now the longest. The same idea is true in a right triangle. In a right triangle, we have a 90-degree angle. That's why the triangle is called right, because there is a right angle. The right angle in the right triangle is the largest angle, because the total of the angles in any triangle should add up to 180. So the sum of all angles would add up to 180. Therefore, the largest angle, in this case the 90-degree angle, will be opposite to the longest side. The longest side is called the hypotenuse. The hypotenuse is the longest side in a right triangle and is opposite to the 90-degree angle. The other two sides are called the legs. So there's the short leg and there's the long leg. Now I would like us to watch a tutorial video, about 2 minutes, explains Pythagorean theorem in a dynamic and fun way. As we saw in the YouTube video, the Pythagorean theorem states that the square of the hypotenuse is equal to the sum of the squares of the other two sides. This relationship helps us calculate missing sides in a right triangle. It is important to note that the letter C in the rule a squared plus b squared equals c squared is always used to refer to the hypotenuse, while A refers to the short side and B refers to the long side. So now let's look at an example. The rule a squared plus b squared equals c squared can be used to find the missing leg in that example. It is sometimes difficult to figure out which side is A and which side is B, especially if we're just beginning to start practicing Pythagorean theorem. It is clear, however, which side is the hypotenuse. In this case, the hypotenuse is 5 because it's opposite to the 90-degree angle. As we stated before, the hypotenuse always refers to the letter C. It does not matter if you use A as the missing side or B as the missing side, since they're both being added. So I will write the equation again by plugging in the numbers for the given sides. So I know 5 is the hypotenuse, so I will plug that in for C. And I know that the missing leg is either the shortest A or the long side B. I will plug in 4 for B. I will simplify by squaring the numbers. Then I will combine like terms by subtracting 16 from both sides. So I will have a squared equals 9. And by square rooting both sides to find a rather than a squared, I will find that a equals 3. It's a good thing that we used a for the missing side because it is the shortest side. Yet if you would have used b squared as the missing side, you would have gotten 3 as your answer still. In this example, we are actually missing the hypotenuse because it is the side opposite to the 90-degree angle. So we are missing C. So in the rule a squared plus b squared equals c squared, I will be plugging in the numbers I'm given for A and B because I am missing C, so I won't be plugging in any numbers for that. Rather, I'll be trying to find it. By plugging in 8 and 15 for A and B, I can rewrite the equation as 8 squared plus 15 squared equals c squared. I will simplify by squaring the numbers. Then I will add 64 plus 225 to get 289 equals c squared, and then I will square root to find c. And in this case, square root of 289 is 17. So the hypotenuse, or c, is equal to 17 units. Pythagorean theorem is often used in real-life contexts to help us solve real-life problems. For example, painting a wall. Painters use ladders to paint on high buildings and often use the help of Pythagorean theorem to complete their work. The painter needs to determine how tall a ladder needs to be in order to safely place the base away from the wall so it won't tip over. In this case, the ladder itself will be the hypotenuse. Take, for example, a painter who has to paint a wall that is about 3 meters high. The painter has to put the base of the ladder 2 meters away from the wall to ensure it won't tip over. What will be the length of the ladder required by the painter to complete his work? A good idea when solving real-life problems is to always draw a picture. Drawing a diagram will help you figure out the missing side and help you determine which rule to use. So drawing a picture like this would help me understand that the hypotenuse is the missing side. The ladder in this case is like the hypotenuse. And as we discussed before, the hypotenuse is c in a squared plus b squared equals c squared, or the Pythagorean Theorem rule. So by plugging in the given sides, 2 and 3, in the formula a squared plus b squared, I can then simplify and find c. By simplifying, I can find that 4 plus 9 equals c squared, and that c squared equals 13. It's not a perfect square, but using a calculator can help us figure out the square root of 13. By using a calculator, I can find the square root of 13, which is about 3.6. So therefore, the ladder that is needed by the painter to paint the wall is about 3.6 meters. Using this example, I would like you to try another problem and bring it to class. So the problem you're asked to do right now is a story or an application. Let's say two friends are meeting at a playground. Mary is already at the park, but her friend Bob needs to get there, taking the shortest path possible. Bob has two ways he can go. He can either follow the roads getting to the park, which is first heading south 3 miles, then west 4 miles, for a total of 7 miles. Or the other way he can get by cutting through the open fields and walking directly to the park. Draw a diagram and apply your knowledge to fill in the blank. Walking through the field will be blank miles shorter than walking along the roads. Try this problem and bring it tomorrow to class so we can discuss it and you can share with your peers. Thank you.